In October 2017, a startling alarm rang out across Earth. For years, we've been vigilant, scanning the night sky for near-Earth objects, usually just mundane rocks. But then came October 19th. The Pan-STARRS telescope in Hawaii spotted something extraordinary. This object wasn't orbiting the sun. It was diving through our solar system in an unexpected vertical path. It moved impossibly fast, too quick to be ensnared by the sun's gravity. Originating from the direction of Vega, it raced past our planet at a staggering 196,000 miles per hour. By the time we grasped its significance, it was already streaking away. We named it Oumuamua, meaning a messenger from afar arriving first in Hawaiian. This wasn't just poetic, it was telling. Like in military strategy, where you send a scout first to evaluate and report back, Oumuamua was our cosmic messenger, a small, elusive visitor testing our defenses.
For weeks, astronomers were in a frenzy. Was it a comet, an asteroid? Today, I'll reveal why it was neither, because it appeared to be something far more intriguing. The clue lies in a specific number, the non-gravitational acceleration, suggesting this wasn't just an ordinary rock. To grasp the strangeness of Oumuamua, we first need to understand what normal looks like. Typical space rocks are irregular, potato-shaped, tumbling, and slowly becoming rounder. But Oumuamua, it was an anomaly. As it zipped through space, its brightness fluctuated dramatically, changing by a factor of 10 every 8 hours. This means it must have been incredibly long and thin, with a ratio of 10 to 1, a shape like a cigar or a pancake. Nature doesn't create such elongated objects, but we know what does. The fuselage of a plane or a rocket. Clearly, something unusual is at play here.
Anomaly number 2, the engine. This is the smoking gun. As Oumuamua left the solar system, it sped up. Now, comets do this. It's called outgassing. Ice melts, turns to steam, and shoots out the back like a jet thruster. Simple physics. But here is the problem. If a comet is outgassing enough to push a rock that size, you would see it. You would see a tail. You would see water vapor. We looked with the Spitzer Space Telescope. We looked deep. Nothing. No water, no dust, no gas. So, it accelerated like a rocket, but it had no exhaust. The scientific community scrambled. They said, maybe it's a hydrogen iceberg. The hydrogen is invisible. But hydrogen icebergs are theoretical. We've never seen one. And physics suggests they would evaporate before they ever got here. So, we have a cigar-shaped object, tumbling under control, accelerating without fuel. Anomaly 3. The light sail. There is one theory that fits all the data. It comes from Dr. Avi Loeb at Harvard. What if it wasn't a cigar? What if it was a pancake? A very, very thin sheet? If you have a thin sheet in space, sunlight hitting it acts like wind. The photons bounce off and push it. It explains the acceleration. The closer it got to the sun, the faster it got pushed. It explains the lack of a tail. No gas, just reflection. It explains the tumbling, a broken or discarded sail tumbling in the solar wind. I want to pause the science for a second. If you were a civilization sending a probe to check out Earth, would you land? Or would you do a flyby to scan our radio waves? Oumuamua passed within a fraction of Earth's orbit. It swept right through the Goldilocks zone. Let me know in the comments. If you were the alien commander, do you send a drone first? Or a manned ship? There is one final detail that keeps me up at night, and almost nobody talks about it. It's called the Local Standard of Rest, or LSR. Think of the galaxy like a swirling ocean. All the stars, including our sun, are moving in a current. We are all orbiting the galactic center. Oumuamua wasn't moving. Relatively speaking, it was sitting at a dead stop in the galaxy. We hit it. It was like a buoy floating in the Atlantic, and our cruise ship, the solar system, smashed into it. The statistical odds of a random rock naturally being at zero velocity in the local standard of rest are astronomical, 1 in 500. Why would you park a ship at zero velocity? Camouflage. If you park at the rest stops of the galaxy, you don't have to burn fuel-chasing systems. You just wait for a system to pass by you. You sit still, turn on the cameras, and let the planets come to you. So let's review the profile of our scout. Artificial shape, extreme aspect ratio, artificial propulsion, light sail physics, artificial positioning, parked in the galactic heavy traffic lane. That is not a rock. That is a sensor buoy, and it just finished scanning us. In 1492, before the settlers arrived, there were rumors. Strange wood carving washing up on the shore, lights on the horizon. Oumuamua was the driftwood. It was the sign that the ocean isn't empty. But here is the scary part. Oumuamua was small, a few hundred meters. 2 years later, we spotted C2019Y4, Atlas. It wasn't small, it was huge. And it was following a very similar path. The scout came, it phoned home. And then, the heavy transport ships arrived. In the next episode, we are going to look at the Armada. We are going to talk about why Comet Atlas broke up right before it got to Earth, and why that might have been a deployment, not a disaster. Click that video right there to continue the journey. You don't want to miss the landing.